Okay, so today I'm going to be doing a quick lesson on negative exponents. And what we're going to do is go back to one of the previous power laws, and this is actually from the previous video. And I'm going to show how this equation can lead to this equation. Okay. Now again, I'll work this by example, and then we'll take a look at some different ways that this can be applied. Okay. So let's as before, I showed that x to the a divided by x to the b is equal to x to the a minus b. Right, and the example I gave, I think, was 2 to the 4 divided by 2 to the 3. Okay, and what I showed was that is 2 times 2 times 2 times 2, all divided by 2 times 2 times 2. And you can see that these eliminate each other, and we're just left with 2 to the 1, which was equal to 2 to the 4. That looks like a 9 minus 3. Okay, now the question though is, what if this wasn't 2 to the 4 minus 2 to the, and 2 to the 3? What if it was reversed? Okay, so instead of 2 to the 4 in the numerator position, what if it was in the denominator position? So I had 2 to the 3 divided by 2 to the 4. And that looks pretty terrible, so I'm just going to rewrite it. 2 to the 3, 2 to the 4. Okay, and then what we would get there is actually 2 to the 3 minus, 2 to the 3 minus 4, which would be 2 to the negative 1. Okay, and the question is, what does that look like? Well, what it means is that we'd have 2 to the 3 divided by 2 to the 4, which is equal to 2 times 2 times 2, all divided by 2 times 2 times 2 times 2. And, okay, and what we can do is see that we have a bunch of elimination happening here, and we actually have a 1 here, so this is equal to 1 half, which is 1 over 2 to the 1. And from this we can get the general equation that x to the negative a is equal to x, or 1 over x to the a. Yeah, I'll show another example of this here. Okay, so if I have, and the a doesn't have to be a 1, it can be whatever, or it doesn't have to be a squared or cubed or anything. That can be anything really. Okay, so let's say 2 to the negative 3. Okay, well then this would be equal to 1 over 2 cubed, or 1 over 8. And I can show this. So let's say, for instance, I had 2 squared divided by 2 to the 5. Okay, so I would end up with 2 to the 2 minus 5, which is equal to 2 to the negative 3. Okay, and I can expand this and say 2 times 2, and then 2 times 2 times 2 times 2 times 2. We'd have some elimination. We have just 1 left up top, and what we'd have is 1 over 2 cubed. And you can see that they're all the same. Okay, and so these 1/8, 2 to the negative 3, and 1 over 2 cubed is all the same. Alright, now often this will mess people up. What will mess people up with this is when it's not quite so simple. And people kind of make mistakes, some simple mistakes about this. And I'll show you some examples here. I'm just going to move this to the side a bit here. Actually, don't need this. Okay, a common mistake that people make is when you provide them with a negative number. So you end up with negative 2 to the negative 3. And then people sometimes will say, well, we have a negative and a negative, so they just cancel each other out. And then we end up with 2 to the 3. Okay, that is not correct. Okay, in fact, what this is negative 1 times 2 to the negative 3. Okay, so this turns into negative 1 all over 2 to the power of 3. Okay, another common trick that people see, or common instance that people see that gets confusing, is when we have an exponent of an exponent. Okay, so when you have like 2 to the negative 2 all to the negative 2, and then people don't know how to do this. So what this is that we just use our basic order of operations, and so the first thing we do is brackets. Okay, so what's inside the brackets is an exponent, and we have 2 to the negative 2, which is 1 over 2 squared, all to the negative 2. Okay, and then from there would be 1 quarter to the negative 2. Okay, and again, this kind of messes people up when they have fractional things like that. But really, what this is 4 over 1 squared. Okay, and then basically this would turn into 16. Okay, that leads me to the last case I was going to talk about here, and that's when we have basically the same thing but a fraction. So let's say we have 1 over 3 squared, or to the negative 2. Okay, well what that would be is the same thing, is that we basically would end up moving this to the top. Okay, and so this becomes just 3 squared. Okay, now there is obviously a mathematical reason behind why this happens, but an easy way to remember is that this negative sign, okay, is telling you to basically flip this this variable, okay, or this number. So if the exponent is applied to a variable or a number in the numerator, then that number has to be moved down to the denominator. And then if it's shown in the denominator, then that number has to be moved to the numerator. I prefer if people didn't memorize it that way, but it is a quick way to know it. If you do know it that way, you should know at least that there is a sound way of figuring out why that is. Okay, but anyways, that's a quick lesson on negative exponents. If you have questions, once again, drop me a line, send me an email, or put a comment in the comment box.